As you can see in this lesson, we're going to look at rhombi, squares, and kites. So first we have to figure out what these three figures actually are. The first one, the rhombus, that's a quadrilateral where all four sides are going to be congruent. And I just have one little example there where showing that I have a rhombus and the four sides are congruent. You can see the little tick marks on each side. The square, that's going to be kind of like a rhombus in that all four sides are going to be congruent, but all four angles are also congruent. So when you classify it, the square can actually be classified as a rhombus because the four sides are congruent. And then the last one, the kite, is going to be a quadrilateral, a little different than all the other ones that we've talked about. And this is one where it has two sets of distinct pairs of congruent adjacent sides. So when I look at this kite, my top two sides are the congruent ones and my bottom two are the other congruent ones. Where when you looked at other, like a parallelogram, it's the opposite sides that are the congruent ones, not the ones that are right next to each other. So remember that, a kite and a parallelogram are different. Now we're going to look at the properties of a rhombus. The first one deals with the diagonals. So if this parallelogram is really a rhombus, then we know that the diagonals are going to be perpendicular. So as you see in my picture, I've shown now that the diagonals are perpendicular. That will always happen as long as the parallelogram is a rhombus. Now what I want to look at is I want to look at the converse. So I'm going to change my hypothesis and my conclusion around. And then I'm going to write that. Notice now it says if the diagonals of a parallelogram are perpendicular, then it is a rhombus. I want to know, is this true? So what I'm going to do on that is I'm going to kind of do a little proof here. I call this my little picture proof format, where I'm going to take and I'm going to make this parallelogram. I know it's that because I look at the hypothesis, tells me it has to be a parallelogram, and it tells me that the diagonals of this thing are perpendicular. So I'm going to draw my diagonals and I'm going to put in the perpendicular symbol. Now I want to know, is this thing really a rhombus? Well, the only way for me to figure that out is I'm going to have to somehow show that the four sides of this parallelogram are all congruent. Now the way I'm going to do that is I'm going to start off by saying, well, since I know that it's a parallelogram, I know that the opposite sides are congruent. Go 3 there, go 3 there. I know that these two sides are going to be congruent. So that's one thing I can do. Now I look at this and I have these four triangles in here, and I know each triangle has a right angle in it because the diagonals would be perpendicular, and I know that they all, well, two of the triangles, called the top and the bottom, have a set of congruent sides, and the left and the right triangles have a set of congruent sides as well. But I'm going to take another fact about parallelograms, and that fact says that the diagonals bisect each other. Therefore, I know that this little piece and this little piece are going to be congruent, and same thing here and here. Now what I notice is I have triangles that are congruent. I look at this triangle here, and it has a single tick, it has the right angle, and then it has the double tick. And if I look at the triangle below it, it's going to have those same pieces. It has the single tick, the right angle, and the double tick. So I know the top and the bottom triangles are going to be congruent. But then if I come here and I look at this triangle over here on the right, well, I notice in that triangle it also has single tick, right angle, double tick. Therefore, all three of these triangles are congruent. And the same thing is going to happen when we look at the triangle over here on the right. I have single tick, right angle, oops, a little green in there, double tick. So all four of those triangles are congruent, which means all their corresponding parts are congruent. Well, I'm going to need to add another set of ticks here and here because all four triangles are congruent. Now I look at my figure, 3 ticks, 3 ticks, 3 ticks, 3 ticks. All four sides are congruent, therefore it is a rhombus. So is the converse true? Yes, it is. Now, this one, be careful because this is a very important part of it. The diagonals are if the diagonals are congruent in a parallelogram. If it's something other than a parallelogram and the diagonals are congruent, it's not necessarily going to be a rhombus. So please keep that in mind. My next one is going to say if the parallelogram is a rhombus, then there's something else that we know about it. And this one's going to deal with the angles So then each of these diagonals is going to bisect the angle that it goes through, I think of. So here and here, those two little angles are going to be congruent. The diagonals bisecting the angle of the rhombus. Same thing happens with the other angles. Now I'm going to move on to the kites. So now if this is a kite, which when we look at it, it is because I have the two sets of distinct, congruent, adjacent sides. What do we know about those diagonals? Well, this one's similar to, well actually, sorry, that's another one I'm thinking of. In this case, I'm looking at the long diagonal is going to bisect the short one. And that will always happen. It's always going to be the long one. Now, when you look at this, and I know we can't always go by what it looks like, but the short diagonal is not going to bisect the long one. It's just the long one cutting the short one in half. My next one is, now I'm just going to look at the long diagonal. So if it's a kite, the long diagonal is going to bisect a pair of opposite angles. So the two angles that the long diagonal goes through, it cuts those two angles in half. But it's only the long diagonal again, not for the short diagonal. And then this one, going back to the two diagonals again, those diagonals are going to be perpendicular. So this one's kind of like the rhombus, where the diagonals are perpendicular to each other, but many of the other properties about diagonals in a rhombus are not going to follow up with the kite. But this one does. And then that's going to conclude my lesson part on squares, rhombi, and kites. A little different order than what we started with.